Okay, this is the part C of this question. That was from the 2012 WACE exam paper. And we're required to prove one of our log rules that we all know, natural log of x, y is equal to natural log of x plus natural log of y. Using this definition for natural log of x, okay, so integral between 1 and x of 1 over t dt is natural log of x. I guess, sort of our alternative definition for natural log of x, if you like. As a bit of an aside, you could, if we're looking at natural log of x, it's really, as we know, log base e of x. We might even call that y, make an equation in log form. I like to compare it, when I'm sort of not sure what's going on, to a log base 10 of 100. But I know that's equal to 2. Okay, and in terms of the exponential form of that equation, it would be 10 squared equals 100. 10 squared equals 100. So exponential form, logarithmic form, we can apply that to our natural log as well. So here it was 10 squared equals 100, so it's e to the y equals x. So, log base e of x is really just another way of writing your exponential here. And in fact, if we change these variables over to make this y is equal to e to the x, changing the variables, we've got our inverse relationship. So we can say, that's really the same as that. Change the variables, it means that y is equal to e to the x is an inverse relation to y is equal to natural log of x. Another part of the syllabus. But okay, let's get back to the question. Okay, so we're going to use this definition to prove this log rule. We can start off with our natural log of x, y, and just use this definition with x, y instead of x. So we've got the integral between 1 and x, y of 1 over t dt. Here comes a little trick, I guess. Because we want to use this natural log of x, and we've kind of got an eye where we're going here. You want to generate a natural log of x here. We split up this integral into two separate integrals. First one being between 1 and x, 1 over t dt. So lower bound of 1, upper bound of x, which is sort of in between 1 and xy. And then we use x as the lower bound here, and then up to the upper bound of xy. Now what that does is, separating this integral out into the two separate integrals, is that the first half here is this definition here. So we've already got natural log of x from that part, plus integral of x, integral between x and xy of 1 over t dt. So we're halfway there, we've got that one. We now just need to show that this expression here, hopefully will equal natural log of y. Okay? Now to do that, we need to make a substitution, and the tricky part, I guess, is what substitution are we going to use? We're going to use u is equal to something. Now, I guess the key here is remembering that these boundaries of the integral are actually t values, even if it's got x there. Because we're integrating with respect to t, this is t is equal to x, this is t is equal to xy. So when we change the variable to u, from t to u, the substitution we want to make, we want it to generate a 1 here, so it agrees with our definition up here. Okay? So, what we can do here is if we make this u is equal to t over x, when t is equal to x, we'll get x over x is equal to 1, which is what we want. So that's the substitution we go with, and then we're hoping that this top part here falls out nicely as well. Okay, so we'll try that substitution now. So we've got natural log of x plus, so working these two values out here, we've got, when t is equal to x, we've got x over x, which is 1, so that becomes 1. Okay, when t is equal to xy, t is that, so I'm going to put this over here. T is equal to xy, we'll get u is equal to xy over x. X is cancelled, we get u is equal to y. Perfect. Exactly what we're after. We want a y here, because we want to get natural log of y. That's, looking good. Okay, now the other thing we need to do is we want to substitute, so we're integrating with respect to u. So we differentiate this one here. Now, what do we differentiate with respect to? We want to substitute for dt. So we differentiate with respect to t. So we find du dt, in other words. So we've got du dt derivative of t is just 1, so we get 1 over x. And rearranging that slightly to get dt by itself, we get dt is equal to x du. dt is equal to x du. So for the dt here, we can substitute in for x du. Now we've still got this 1 over t here, and we've got an x here, so a little bit problematic because we want this to be 1 over u. We can get it to 1 over u du, we're all good. Okay, so we'll go up the board over here and see if we can sort that out. So we've got natural log of x plus the integral of... Okay, so we've got 1 over t x du, so perhaps what we can do here is rearrange this one here. We know that we've got substitution was u is equal to t over x. We can rearrange that a little bit to get t by itself. We've got t is equal to u times x. So we can substitute that in here for t. So we'll get 1 over ux, and we've still got this x value there, which is going to cancel. du, so those x's cancel, and we're left there with natural log of x plus integral. I better put my boundaries and my integral back in there. There we go. 1 over u du. And we can see that this here is really the same definition up here, except that we use variable u, du here, 1 over u, and we've got a y there, so we'll generate natural log of y instead of natural log of x. So we get our answer here of natural log of x plus natural log of y as required. Okay.